All right, welcome everybody. You've got an exam coming up and a homework assignment. Homework 11 due Friday, is that right? Yeah? Okay. I just wanted to make sure because, you know, I recycle these slides from semester to semester and sometimes I forget to adjust the announcements. But yeah, now that I think about it, you do have a homework assignment due on Friday. How could you not? Some of you have signed up for taking the exam early. The location of the early exam is just down the hallway on the right. It's room 1228. That's the hydraulics lab. So if you're signed up for the early exam, then it's at 2:30 p.m. tomorrow. If you're signed up for the Friday exam, then it's at noon. You know, our normal time, normal location. Sorry. You gonna make it? All right. So the exam has two parts, the concept questions where you're basically doing short answers and you don't use your equation sheet on the concept questions. Then in problem solving, you need to bring a computer because you'll benefit from access to Microsoft Excel. When you use Microsoft Excel, then you're just starting with a blank worksheet. You can't use any of your previous homework assignments or in-class exercises. You're just starting with a completely empty file to solve the problem. Now you can prepare a page of notes, as I've explained before, and that page of notes can include anything you'd like. It can be handwritten, it can be typed, it can be whatever you want on that page, front and back. And so any formula that you feel like you'd need to have access to for problem solving, you should put that onto the equation sheet. For example, I won't be giving you the B to C formula. That's not on the time value of money equations that I will be providing. So that formula sheet can include column titles for different Excel solutions you've seen before, or procedures, reminders. Now, the thing that you should be thinking about after the wave of relief of finishing that exam and you feel like you've got not a care in the world, well, you've just got one care in the world during spring break. That's working on the project. The project's due on Friday the 19th, and there's just the same trend every semester that the students who get the highest grade on the project are the ones who get started early. And the students who are throwing something together at the last minute, they usually make mistakes or forget things and make errors in their writing, and just the grades aren't quite as high. So if you want to do well on the project, I'd encourage you to get an early start and maybe spend some time during spring break working on that. Any questions about the announcements? Yeah.
On the Excel part of the exam, will we need to like how homework, will we need to annotate what we're doing, like explain like what each step means, or do we just kind of fill it out?
The more you can do to help me understand your solution, the more likely it is I'm able to give you partial credit if you make a mistake. And if I can't find the answer on your spreadsheet, I also can't give you the credit. So I don't want to say it's required for you to annotate and explain in a lot of detail, but I think that's a really good habit, and it'll help me to be generous with you if you don't get the right answer. That's a great question. Are there other questions? All right, well, I've got one review question for you. What is economic service life? Okay, it's the ideal amount of time to own equipment compared to replacing it. And how do we know, like if we're doing an analysis and you've gone through the procedure, bing, bang, boom, you've got some column that says costs, what's the way of knowing what's the correct number of years to own something? Exactly right. Whichever year has the lowest annual worth of costs. All right, we're doing that same thing today. It's important, so I include that economic service life analysis in 2 in-class exercises. So replacement and retention decisions is just doing economic service life analysis with multiple alternatives. All right, So consider if you're working at some sort of a chemical plant or an industrial facility, existing equipment may look outdated, but possibly it still does the job. You can see these analog dials and a guy with a hard hat, and he's manually kind of keeping tabs of some industrial process where increasingly newer factories and plants are being built with automation and computer controls. Automation and computer controls sometimes has drawbacks, especially when it's installed in a Boeing airplane, right? But I mean, generally, automation does good things because computers make fewer mistakes than people. Computers don't fall asleep, like this guy maybe could fall asleep. Maybe this guy's drunk and asleep, and we just don't know it, right? But the computer doesn't get drunk or fall asleep, although it might just nose down suddenly. So that's been in the news lately, the debate between automation and human control of things that are complicated, like flying a plane. The question often becomes, can you save money if you automate? And so if you want to minimize your costs, you're going to be comparing some existing thing that you own to a new alternative. The existing thing you own, we're calling the Defender. This new alternative that could replace it is the Challenger. And when the analysis we're doing today, we assume that both of them will achieve the objective. You know, that you can, if this is a chemical plant and they're making plastic, you can make plastic regardless of whether it's manual observation of analog dials or automated control of a digital system. So they both meet the required specifications, and so the income is being generated, but we're not focusing on that because they both generate the same income. All we're focusing on is the differences, and the differences arise in the costs. Sometimes a study period is specified, like a certain number of years that you have to compare. You know, like if you've got a 10-year horizon and both alternatives are going to be compared on a 10-year horizon, then there's one way to analyze that way. Sometimes no study period will be specified, in which case what your approach would be is you just pick the economic service life. You just pick the alternative that has the lowest annual worth of costs and you keep it for that number of years. The assumption being that at the end of that economic service life, you'll revisit the question of what should you own now. What's the cost of your existing equipment? The stuff that you already own, how much does it cost? What's that? Zero. That's what I was hoping you'd say. It's a trick question. It's not zero.
Market value of what you would get from.
It's the market value, because you have to remember there's the opportunity cost. The stuff that you already own, if you keep it, you have to pay the value of your second best option. And the value of your second best option, if you decide to keep it, that means that you decided not to sell it. And so selling it was your second best option, and you could have sold it for the market value. So if you have some piece of equipment that maybe has a market value or could be salvaged, if you hold on to it, what we're going to assume, and specifically for today's in-class exercise, you have to assume that the stuff you already own, its first cost is the market value at the present. And so that's how we handle costs. So let's say that we're going to do a replacement study when there's no study period specified. That's going to be the first in-class exercise you do. I've got a 2-pager for you, and on the front page we're going to say that there isn't like a 10-year horizon we necessarily have to consider. It's just however many years is the lowest cost is how long we'll own the thing. So we do an economic service life analysis for both the Defender and the Challenger, and then you pick the alternative and the timeline that gives you the lowest cost. Now in the real world, when you do that, generally you would perform an annual update on the comparison. You know, every year you'd be asking yourself, should we keep the old stuff or buy something new? It's not like you do the analysis today and your analysis says, keep the old stuff for 4 years, and then you'd wear blinders until the end of that 4 years. I mean, you'd revisit this decision every single year to make sure that maybe the assumed data hasn't changed, or maybe the costs have shifted on the automated equipment. So the point that I'm making is when you do your initial analysis, it may tell you to keep something for 4 years, or maybe buy the new equipment and keep it for 7. Even when you know which direction you're going to make and you make that decision, you still have to revisit that analysis just to make sure that things are turning up the way you thought they would. I got an email from someone who said that they have some rental properties and they want to understand, are they making money? And so I suggested external rate of return analysis to that person. It's a student. And I think he's owned these rental properties for a few years, and he's probably put in a lot of work to fixing them up. And collecting money from your renters is a little bit of work, and fixing things when they break. And he's just wondering, what if I just put that money in the bank? Am I better off owning rental properties when it takes me this much time? He's trying to figure out a way to revisit the decision rather than just moving forward blindly with the idea that I'm going to be a landlord now. The point is you have to do follow-up studies. All right, last time I provided a template. This time I want you to prepare your own template from a blank spreadsheet. The reason why is I think it'll reinforce your memory a little bit and help you to understand what goes into each column if you prepare it yourself. So I've given you a suggestion of what the setup should look like. So we've got 2 alternatives. You need to translate the problem statement into cash flow table. There's a defender and a challenger. And what we know about the existing equipment is we've got the market value, and then the market value is declining by 20% each year. So that means in year 1, the market value will be 0.8 times the market value in year 0. So by 20% decline, that means it retains 80% of its value. Operating costs are specified for the existing equipment. And then you know some stuff about the proposed equipment. Cost $50,000, last 6 years, market value. So the question is, find the economic service life of both alternatives. This is the same procedure that you did before. You'll notice that here in column D, you're doing the net present value function. Remember, we used NPV for whichever row we were on. All of the cells, that row included, and the one above it of the operating costs. Column E, you're using the payment function, and it's a present value that's going into the payment function. And then in column F, for capital recovery, you're using the payment function again, but you're including the first cost and the market value. So that capital recovery idea where both of them have to go in there and both of them get the negative sign. All right, so let me pause for a moment, and hopefully you'll be able to knock out this economic service life analysis a little bit faster than you did on Wednesday, and that'll be good practice for the homework and potentially for the exam. Yeah, 10%. All right. If you haven't finished yet, save what you're working on and pause for a moment, because I want to just talk you through a few important things here in the solution. I don't think you'll have time necessarily to finish, because I also want to show you what to do if the study period is specified. Okay, so let's review a few things. The first cost is negative for the defender, going back to the idea of if you keep your existing equipment, you lost the opportunity to sell it, and so it's treated as though that's an expense. But its market value is positive, because these amounts that are listed under MV, those are the amounts that you'll get as an inflow when you finally do sell it. So if you keep it and then sell it after 1 year, the keeping it now is an outflow, but then the selling it in 1 year and getting $12,000, that's an inflow. All right? Operating costs are outflow. As I was walking around, I noticed a few people had neglected the negative sign for those operating costs, and that'll change everything if you don't clearly differentiate between what's an inflow and what's an outflow. When we use the PV function, when we're finding the present value, we're using the NPV function, and it would get tedious to type the NPV function in so many times. So what you can do is you can anchor the first reference and then drag it down. See how right here what I've got anchored is the reference to the interest rate, and then I've got the reference to C15 anchored. I've just anchored the row reference. I guess I could have also anchored the C. It wouldn't change anything, but I didn't anchor the one on the bottom. So if I set this up here, I'm saying NPV, so the rate, there's my interest rate, and then the first reference here, I'm anchoring that, but then I'm also including in the range C16, not anchored. So that now I don't have to type the NPV function in a bunch more times. I can just drag it down, and it knows to extend the second number in that range to whichever row you're on. Just a time saver there as far as anchoring the first number in the range. Okay, annual worth of operating costs. What we're doing is we're taking these present values and we're re-annualizing it. So we're spreading out the operating costs so that it would be the same operating costs every year for however many years. So what this means, for instance, is that if we keep it for 4 years, if you actually own it for 4 years, then your operating costs are going to be different every year. They're going up. But this column says if you keep it for 4 years, the annual equivalent of your operating costs is $7,762. So it's like converting, instead of paying a different amount each year, it's how much you would have to pay the same amount every year to cover those operating costs. So it would be $7,762. And then capital recovery takes into account both market value for the year that it's being sold, and that's in the future, and then the first cost is being treated as a present value. So we're finding the capital recovery being the difference of those and the annualization of the difference between the first cost and the market value. So in the end of these options, it's best to keep the defender for 3 years. Now this is an example where no study period is specified. We're out of time essentially. We've got 4 minutes for me to tell you about what I was going to have you do on the second problem. So take a look at the cash flow diagram, and I think you'll get an idea of what's happening in the second problem. In the second problem, there's 2 options. The first option is some new equipment, the Challenger. You pay a lot now, keep it for 10 years. In this example, you have a 10-year replacement study that you're doing. So you have to compare them both over the same 10-year time frame. So what we do is we assume we're going to keep the old equipment for 3 years, and then we're going to replace it with something else. The replacement is actually buying the Challenger, but just buying it at year 3 instead of buying it at year 0. So in this example, what you have to do is find the annual operating cost and the present value. You take everything and you annualize it over the 10-year horizon. So it's been a while since we did any time value of money stuff. This problem is hand calculations. You'll notice that I provided the 10% table for this problem because my intention was I wanted you to practice, for example, find A given P. Remember that sort of thing? Where you'd take that $750,000, spread it out over the 10 years. Find A given this P of 70,000. So you'd have to spread that 70,000 over all 10 years. The annual operating costs are only given years 1 through 3. So what you'd have to do there is take it from A to P and then spread it from P back over all 10 years. And then we've got these two different amounts in years 4 through 10. So your procedure there was going to be find P given A. So you take both of those to year 3, from 3 to 0, and then from 0 to 1 through 10, the annual series. And so let me just show you what that looks like. I mean, it's nothing that you haven't done before. It's just been a little while, so maybe it seems unfamiliar. Let me pull it up. All right. So that second one was going to be crunching the numbers with the factor table, kind of a throwback to your earlier days before you're using Excel so much. So we were going to find the annual worth of the Challenger, $172,000 in costs. And then we'd go through the cash flow diagram where we're moving. Basically, my idea was take everything to the present, and then once you get everything at the present, then spread it out over the annual series, spread it out over 10 years. And so if you look, there's 4 pieces to the cash flow diagram. I've drawn here that there's this amount that's already at the present, this amount that is in just 3 years, and we've got these operating costs, that's component 3, and then component 4, although this equipment lasts for 10 years, we're only responsible for 7 years of it. These dashed lines say that we're giving the equipment to some other part of the company after that, and they'll cover the remaining years of its capital recovery. So those 4 components in my hand calculations, what I did was I took them all to the present and then found the annual worth with that big, massive sum total, annualized it, and it was $140,000 per year. So the answer was, what should we do? Should we use the Defender or the Challenger? If we buy this new equipment in year 0, the annual cost is $172,000. If we use the existing equipment, the stuff we already own for a little while, and then buy the new stuff later, it ends up being cheaper that way. So I'm sorry that we didn't have the time to go through those refresher calculations, but that's it for today. Remember that when we get together tomorrow or on Friday, it's exam time. So you need to prepare that equation sheet, and if you've got any questions between now and then, feel free to stop by my office or send me an email, and I'll try and help you out. So have a good day.